Don't understand. Give me a little nod that says, "Oh, no." Today what we're talking about is based on this one simple little premise, Jacob. One simple little premise here. If you take anything and multiply it by 1, you get what Kelvin presented. The same number. Okay, even if it was a fraction. If I take 1/3 and multiply it by 1, I am obviously, following that same rule, going to get 1/3. This would be the part where you would nod in agreement, because that makes perfect sense at this point, doesn't it? Now, put that on the proverbial back burner of your brain, and let's look at just the number 1. We learned long ago that if I have one thing, and I'm talking about fractions, I can make just oodles and scads and a ton of things that are the same thing as 1. For example, if I cut 1 in half, and I have 2 out of those 2 pieces, that fraction means the same thing as 1, right? Or if I cut it into 3 pieces, or 4 pieces, or 5 pieces. Those fractions all are the same thing as 1, correct? This is again a part where you'd say, yeah, that makes a lot of sense here. A little weak in the repeating part here. Okay, if you take this and combine it with this, you get what we're going to talk about today. In other words, if I take a fraction, let's say my 1/3, and multiply it by 1, but let's say we don't use the number 1, we use something over here that is the same as 1. For example, let's pick the 4/4. If I take 1/3 and multiply it by 4/4, that's the same thing, and the book will do this. They'll actually they'll be really clever, and they'll put like this 4/4 inside the body of a 1 to get you to understand that this, in fact, is the same thing as a 1. When I multiply that out, I don't get these same digits. I get 4 times 1 is 4, 3 times 4 is 12. But they're different digits, but they mean the same thing. They are equal fractions. And I know you knew this already, but I thought I'd try to humor you with that. Okay? The gist is this, boiled all down to the simple simmering pot, okay, is that you can make, and we should write this down. I wish I had left my, I'll write it right here. You can make equal fractions by multiplying both the top and the bottom of a fraction by, I'm going to start writing backwards now, the same number. You might need a mirror to fix the rest of those. And simply that just means this, boys and girls. Uh-oh, Eli's squinting. I've never seen him squint before. You can make equal fractions by multiplying both the top and the bottom of a fraction by the same number. In this case, I multiply both the top and the bottom by 4. I got an equal fraction. Now here, this would be the ultimate case here. I'll go back later if you need it. I've already lost Kayla somewhere in this. If I have 3/8, children, I can make an infinite amount of equal fractions just by multiplying the top and the bottom by the same number. Let's start off easy. Multiply them both by 2. I'm going to get 6/16. It is the same fraction. It's an equal fraction. It means the same thing. Okay, but we always use the smaller one because this is easier to understand. If you ate 6/16 of a pizza, you'd eat 3/8 of a pizza. It's just the same thing. Well, I can do the same thing if I multiply both top and bottom by 3. What do I get if I multiply by 3? I get 9/24. I can get the same equal fraction if I multiply by 4. If I multiply by 4, I get 12/32. And I could do it by 5 if I like. by 5 if I like, and I end up with 15 over 40. I could do it by, I don't know, let's go do it by 25. If I have 8 quarters, I have $2. If I have 3 quarters, I have 75 cents. The fraction 75 over 200, boys and girls, ladies and gentlemen, is the same exact thing as 3/8. But in math, when we need to, or when we finish any problem, we always bring her back down to the bottom. That's what we call reducing because it's easiest to understand. They mean the same thing. All right? Now here is what the book will do in, well, a couple things they're going to do. Write these down. Sometimes they will do this. They will go 3 over 4 equals a question mark over 24. And what you need to do on your paper, children, you are 6th graders. Some 5th graders are having a hard time getting this whole writing problem working down. You'll write this down on your paper and just draw myself a little arrow here. How do I go from 4 to 24? I multiply by 6. Oh, so to make an equal fraction, I just have to multiply the top by the same number. 3 times 6 is 18. And it would be the same thing if you were missing the bottom number. Let's say I have 7/8, and I want to write a fraction that has a 21 on the top. What would the bottom number be? Well, you just have to kind of think to yourself. Not out loud, preferably. 7 times what is 21? 3. So 8 times 3 is 24. It's a pretty simple little thing. Did we do it last year? I'm sure we did.
Yeah, we did.
I don't want to like sound beneath you there. Christine.
So for these, the bottom will always be bigger than the top.
I believe they'll give you proper fractions, but it really doesn't matter. That's the point would probably be moved. Now, here is where most and a lot struggle with, and I don't know why, but it's the same here. Write this problem down. Write, oh great, there we go again. Grace needs to come to the office. Grace, I'm guessing that means you.
Well, I have less than 42.
You will. Because you know. Because it's all about the mathematical experience. Here's the problem, write 1/2 and 1/3. Wait, maybe I didn't do it right. As fractions with denominators as fractions with denominators of 6. Then add. And people look at that and go, oh, what does that mean? Well, children, you gotta take it one step at a time. I want to write 1/2 with a denominator of 6. That's what we just did today. What would go on top? If the bottom's 6, you're multiplying both the top and the bottom by 3, so the top is 3/6. Now I have to do the same thing with 1/3. 1/3 with a denominator of 6 gives me, oh, look at DJ's all over that, 2/6. That's step number 1. Change those so they have denominators of 6. Then add them together. Well, if I take 3/6 and I add 2/6 to it, I get 5/6. And that, boys and girls, is the only way to add fractions together that don't have the same bottom numbers. You have to make them the same bottom numbers. So the book's kind of slyly trying to trick you into being able to add fractions together that you couldn't have added together before. Another example of that or not? You do another example of that, or you get it?
I get it.
You're on.